In this unit, we're going to study trigonometry. In this lesson, we're going to study the cosine ratio. All right, everybody, in this lesson, we're going to take a look at the cosine ratio. And this is just another of the trigonometric ratios that we're going to be working with, cosine. It's just the name that we give it. Now, in this case right here, you can probably tell that it's going to relate the adjacent side and the hypotenuse of a triangle. Okay? So, we're going to go through, just like we did with in the previous lesson here, with the sine ratio, we're just going to go through and grab this little bit of information just to illustrate for you what the calculator is doing. So remember, we are looking for the adjacent side and the hypotenuse side, I can't believe I said that, the adjacent side and the hypotenuse in each of these triangles here. So here's the angle that we're given, 36.9. The adjacent side, because remember, this will be the opposite over here, this is the hypotenuse, the adjacent will be 4, the hypotenuse will be 5. If this is the angle right here that you're given, the reference angle, the hypotenuse here is 16. The opposite side is way over here, so the one that's left is the adjacent side, 14. Here's the 68. The opposite to the right angle is going to be the hypotenuse. And then, again, what's opposite the 68, that's going to be your opposite side. So the one that's left here, that's the adjacent side. So now, in the next column here, we're going to write the this ratio here, the adjacent side divided by the hypotenuse. Okay, so first of all, as a fraction, and then we're going to go through and come up with a decimal for each one. So 4 divided by 5, 0.8. 14 divided by 16, 0.875. 3 divided by 8, 0.375. Now normally I wouldn't typically take these more than the hundredth spot here, but now we're going to take a quick look at the cosine of the given angle. So we're going to look for the cosine of 36.9 degrees. Then here this is going to be the cosine of 29 degrees. And here we'll have the cosine of 68 degrees. And now I'm going to go to my calculator and let my calculator tell me what all those are. So, and remember, my cosine button is going to be the button right next to the sine button here, cosine. Cosine opens the angle, parentheses there for the angle, so 36.9. And I get 0. This is approximate, like 0.799, but if I round that to the nearest tenth, like we're seeing right there, I get 0.8. Cosine of 29. If I round that to the nearest thousandth spot there, whoops, and I push that up there, 0.875. This is remarkably close here. And then cosine of 68. And again, to the nearest thousandth spot there is 0.375. So now again, we're off by a little bit because the angles aren't exact. The ratios aren't maybe not necessarily exact, or the angles aren't necessarily exactly correct here that we're given here. They've all been rounded. But what you should notice is that the last two columns are the same. And so that is the significance of the cosine ratio. It is the ratio of the side adjacent to the angle divided by the hypotenuse. It's just a shortcut for getting that particular ratio. So if you think about that last video that you might have watched there that dealt with the sine ratio only relates the opposite side and the hypotenuse. So in this case, I needed something else to deal with the adjacent side. So cosine is A over H. And one short way of memorizing it is cosine is adjacent over hypotenuse. And you're going to see there's going to be a shortcut for dealing with that coming up shortly here. But here we go. So to find the unknown side lengths or angles using the cosine ratio, the cosine of the angle is the adjacent side, the length of the adjacent side over the hypotenuse, length of the hypotenuse. So just like we did before with the sine ratio, we're going to label everything in terms of hypotenuse, opposite, and adjacent. Okay. We're going to use the cosine ratio if we're looking at the hypotenuse and the adjacent, if we've got numbers or values or even a variable if we're looking for one of those. We're going to replace values or the variables with measures if we've got them. So theta will always be the angle. Adjacent hypotenuse will always be the side lengths that correspond to those sides. And then to solve for the unknown variable here, we're going to remember that opposites. Okay, to undo the operations that you see them, we're going to remember setting up the ratios, cross multiplying and dividing. And if we're looking for the angle, we're going to use the inverse cosine function, okay, or that second cosine function on the calculator. So now let's take a look at some examples. Okay, so here we go. So find the unknown in the triangles below. So round any side lengths to the nearest tenth, any angles to the nearest degree. Okay, so this is going to run very similar to what we would have done in a previous lesson with the sine ratio here. So first of all, we look for the angle. And I know it's hard to see here, but the angle here, theta, is going to be 35 degrees. Okay, I don't have the side opposite. I don't know what that is, but I do have the hypotenuse. And there's a variable here for my adjacent side. There's an a there. Okay, so that means I'm looking for the adjacent side here. So when I put, adjacent over the hypotenuse, I don't know the adjacent, but I do know the hypotenuse is going to be 20 here. I don't have the full ratio, so I don't know what that ratio is supposed to be, but I do have a cheat, because when I type in the cosine of 35, the calculator will tell me what this ratio is supposed to be. Okay, so now I pull out the calculator, cosine of 35, and just like I did previously, I'm going to go to 4 decimal places here, so 0.8192. So this will be 0.8192, and that's a over 20. And I can always think of this ratio here as being a number written over 1. And now we'll cross multiply. A times 1 is a, and this will be 20 times 0.8192. But when I actually do the calculation, I'm going to leave that number in there, multiplied by 20. And to the nearest tenth, I will get 16.4. So, 16.4 feet. And feet, because I saw that it was 20 feet there. For this question, the angle that we're given is the 73 degrees. I don't know the side opposite. Okay. The hypotenuse in this case is the unknown, but I do have the other side here, which has to be the adjacent. So the adjacent is this 9.5. So the adjacent over the hypotenuse is going to be 9.5 over b. I'll just use the same variable they've used here. I don't have the complete ratio, but I do have the angle, which allows me to do a little cheat here. I can use the calculator to get that ratio. And 9.5 over b will equal the cosine of 73, or 0.2924. And I can always think of that as over 1. And now I'll cross multiply. So 9.5 times 1 is just 9.5. This will be b multiplied by 0.2924. Now, because the variable isn't by itself, I've got one more step. I got to divide by that coefficient, so that was 0.2924. And so here, it will be 9.5 divided by that number that I just came up with. So divided by the answer that I just found. And I'm going to get 32.5 centimeters. And roughly, I'll put a little dot over that to indicate that I rounded there. Okay, so there you go. That's how we're going to find that missing side here. And I do take some encouragement from the fact that that side is longer than the leg there, because it's the hypotenuse. It should be substantially longer. Now here for this one, notice in this case here that they've indicated this angle here, but they haven't told us what it is. But they've given a little mark here to say that this is the angle that's important. Now it's not written in, and it really should have been. This is supposed to be the right angle. Now I could verify that this is the right angle, that was the right angle, by just showing using the Pythagorean theorem to show that these sides here actually work. 8 squared plus 6 squared actually is 10 squared, and in fact this is a triangle that we've looked at in a previous lesson. So in this case here, I know that this is going to be the hypotenuse. This is the opposite, and this is the adjacent. So now it actually turns out here I could use either sine or cosine to figure out what this angle is. But I'm going to use cosine because that's what this lesson is about. So adjacent over hypotenuse is going to equal 8 over 10. And this is going to be equal to the cosine of my angle. Now, for me to get that, because I have the ratio here and don't know the angle, my angle is going to be the inverse cosine of 8 over 10. So on my calculator, I would press second cosine to activate that inverse ratio, and then type in 8 divided by 10. And to the nearest degree, I get 37 degrees. Now, just to show that this is consistent, like I said, we could have used sine for this, and we've seen sine already. Sine is the opposite over the hypotenuse, so that would have been 6 over 10, in which case I would have used the inverse sine of 6 over 10 to get that angle. And let's just take a quick look here. Inverse sine of 6 divided by 10. These should be the same angle because I'm building these ratios with respect to the same angle, and when I press enter, there it is. It's the exact same angle. So that is very comforting that I am on the right track here, that these ratios are working properly. Okay, let's take a look at a couple more questions here. What do we see here? Farmers will sometimes use conveyors on an incline to load grains or other materials onto something high. If Farmer Joe is loading barley into a cylindrical storage container that is 20 feet high, and the angle made between the container and the conveyor is 25 degrees, how long must the conveyor be? Okay, so what they're saying here is that it's 20 feet high, and that the angle between the container and the conveyor is 25 degrees, and then the question is how long is the conveyor? Okay, well, look at the information we're given here. Here's the angle. This would be the opposite side, which means this is the adjacent. And then, because it's opposite the right angle, that's going to be the, oh, it's not the opposite. Wow, that's the hypotenuse. Sorry. In my head, as soon as I thought opposite the right angle, I thought opposite. But anyway, so because I'm looking for the hypotenuse and I do know the adjacent side, I'm going to use adjacent over the hypotenuse. That is going to give me 20 over x. And although I don't know that ratio entirely, I do know a cheat way of finding it. I know that that's going to be the cosine of 25. So the cosine of 25 is equal to, so 20 over x is equal to 0.9063. I'll write that over 1. So 20 times 1 and x times 0.9063. And then I'm going to divide by 0.9063 on both sides. And then finally, on my calculator, leaving that full decimal in there, 20 divided by that answer, and I'm going to get 22.1 feet when I round that. One more question. To hold a new tree upright, Tyson and Gemma tie strings to the top and attach them on 3 sides to the ground, as pictured below. So here we go. Each string is 4 meters long and is attached to the ground 3.2 meters from the tree. So basically, looking at this one right here, this is going to be 4 meters and it's attached at 3.2 meters. What angle does the tree string make with the ground? So we're looking for this right here. So here's the angle that I don't know. We're going to assume that the tree is perpendicular to the ground. So there's my 90 degrees, which makes this the hypotenuse. The side from the ground up to where the connections are, that would be the opposite. I don't know what that is. So this 3.2 must be the adjacent. So my adjacent divided by the hypotenuse is going to be, I was going to write 4, but that's going to be 3.2 meters divided by 4 meters. And that's going to be the cosine of theta. Don't know what that is. So that means that theta is going to be the inverse cosine. Okay, because I know the entire ratio there, I got to use the inverse cosine to get the piece that I need. So on my calculator, that would be second cosine, 3.2 divided by 4. And to the nearest degree, we've got 37 degrees. So that's the angle that's going to make with the ground.